we're looking at a flagpole or a pole, and we want to see how long the shadow is from the pole. Now, usually we were given either the height of the pole or something else whenever we solve problems using trig or similarity. This time we're given a vector. So, right, so let's draw a pole. Not digging that pen size, we'll just do that. Be a flagpole. This would be my flag. It's a happy face. Okay, anyways, we have the sun's shadow here. The sun's going to be red. And let's see, the sun's rays are parallel to the vector 5, 3, -2. In terms of that vector, is that vector relatively steep or relatively flat? If you figure like a certain vector going down at a 45-degree angle, right? Like a vector going like just like this, straight down like this. Is it flatter than that or is it steeper than that? It's flatter. Yeah, because you're going out 5, 3, but you're only going down -2. So I'm just going to draw kind of sun lower in the sky. Something like this. Okay. And this vector's going down here. At 5, 3, -2. Okay, so here's what I did. I thought, okay, here's this vector coming down at this certain angle. Now, most likely, what am I going to create with the vector and the flagpole? A triangle. Okay, we're going to make a triangle with the vector and the flagpole somehow. So if I draw, say, that vector, now I have this right triangle. This flagpole is 8 meters tall. So the way I thought about it is, if I'm going to take this vector is parallel to the vector from the sun. Thank you. What will this vector be? What's the actual length of, not the length of this vector, I mean we're going to get there, but what would the actual name of this vector right here be, since it's parallel? It's parallel to this vector up here at 5, 3, -2. So think about this. How far down is this vector going? If I drew this triangle, this similar triangle up here, it's tough to draw the 5 and the 3, but how far down is this going? That's going down 2, right? So yes, so this vector over here is parallel, so it's the same vector times 4. So this vector would be times 4, we'd have 20, 12, -8. You okay with that? So now if I can find the length of that vector, the length of this vector, then once I have the length of this vector, I can just use Pythagorean Theorem to get the length of the shadow. That makes sense? Does anybody remember how to find the length of a 3-dimensional vector? Or a 2-dimensional vector? What's that? You could do dot product. Not necessarily dot product. Dot product takes 2 vectors, right? And this is only 1 vector. Okay, how would you find the length of just a single vector? Yeah, you just use Pythagorean Theorem. So if you had a vector that was just, say, 2, -4, basically you just use Pythagorean Theorem with those components of the vector. Okay? So I just made that one up. But to find the length of this vector 20, 12, -8, we can just use Pythagorean Theorem with that. And that's called the magnitude. Okay, and it kind of looks like the absolute value bars a little bit. So we could just do the length of this vector would be the square root put L, equals the square root of 20 squared plus 12 squared plus negative 8 squared. Okay. When I did that, I got 24.65. Correct me if I'm wrong on my math there. And that would be meters. So the length of that vector now, from the top of the flagpole to the ground, would be 24.65 meters. And now once you have that, we can solve for the shadow length, B there, and we can just go 8 squared plus B squared equals 24.65 squared. So B squared equals 24.65 squared minus 8 squared. And at this point, I'm confident you can do your math correctly. And I got 23.32 meters. Correct me if I'm wrong on that as far as my math goes, my calculator work goes. Any questions on that?